Okay, everybody, so welcome to our Routing Switching Essentials class for the week of 4/9/18. What I want to do today is go over Chapter 7, which is a very, very important chapter. This is Access Control List, and I can tell you that this is something that gets used over and over and over throughout Cisco's iOS and throughout Cisco offerings. So, very important that you learn it. The good news is we'll go over it a couple times in the curriculum, so this is not the only time you will see Access Control Lists. But it is something that you need to know. ACLs are pretty simple, really, because when we look at ACLs, access control lists, they are really just a series of permit and deny statements. That's all they are. Now, many people think that permit or deny statements. Actually, I know my handwriting stinks, y'all, but I'm left-handed. I'm left-handed.
You got to play with that new toy.
Yeah, I'm left-handed and I've been hit by a truck, so I got both of mine there. But there are a series of permit and deny statements. They can be placed inbound or outbound, and we will talk about that and about placement. And yeah, y'all get to see my new toy. So, unfortunately, I don't have my Microsoft pen. I had the pen that came with. Oh, I lied. Man, I'm an idiot. I did my whole first class and didn't even look over here on the other side and see the other pen. That doesn't make noise. Okay. So, inbound or outbound, they end with an implicit deny. Now, what does that mean?
Something's going to be denied.
Right, but it's not stated, so it's implicit instead of explicit. Explicit, you would see it in the ACL, but they end with an implicit deny. And one thing that we're going to learn is you can only have one per protocol. Can't believe I did my whole first class with that other pen and that other one was sitting right over there. Good thing it wasn't a snake. One per protocol, per port, per direction. We'll go over that much more, but we'll talk about all of these items. Okay. And last but not least, these things are very simple. So they are actually applied and read top down in a sequential order. So that's going to be very important when we start talking about how we build ACLs and the logic behind access control lists. Now, ACLs consist of access control entries, and those are the permit and deny statements. Okay? So they're a series of permit and deny statements. That's all they are. Now, think about what are some uses for access control lists. So we say ACL uses. What are some of the ways we can use them?
Segregate the network.
Segregation. So instead of saying segregation, let's do, can I put down traffic control? Would you agree with that?
Mm-hmm.
And by that, I don't mean security. I'm actually talking about we can use access control lists to do what are called class maps and define traffic and then use those definitions to make traffic go different ways. So traffic control. What's another one?
You can do packet filtering.
Packet filtering or just security. Why don't we just say packet filtering / security? So that's another way we use them. You're going okay, security. You're going to learn about something else. You're going to learn about, how about, can we control access to DQI lines?
We can.
Yeah. Later on, guess what? You're going to learn about ways that ACLs can be used to define interesting traffic for VPNs. And what that means is what traffic will bring the VPN tunnel up, will force the VPN tunnel to be established. Okay? Then there's other uses. There's going to be defining interesting traffic for VPNs, define what should be NATed, define what traffic should be NATed. And I could go and add more and more items here. In other words, And I know natted is probably not actually a real word, but I'm using it. Okay. There are many more uses for ACL in Cisco iOS, but these are just some of them. What we're going to learn in this particular chapter is we're going to learn to do these two items here. So we're going to look at how to control access to V2I lines and packet filtering. As we move into later scaling and connecting courses, you'll learn about how to do interesting traffic for VPNs and also how to define what traffic should be natted. Okay? So here's an example of ACLs, and they're shown as a series of deny and permit statements. Okay? So they can limit network traffic to increase performance, do traffic shaping, flow control, packet filtering. We're doing packet filtering at layer 1, layer 3, layer 4, because our access control entries are able to do some basic filtering. If we're doing extended ACLs, we can do filtering based upon port and protocol. Standard ACLs, we cannot do port and protocol. It's just by source IP. Now, this, I think, is where people get in the absolute most trouble right here. How do I determine inbound and outbound? Imagine there's a little person, and this is the extent of my artistic abilities right there. Okay? Imagine there's a little person sitting in the router in a chair. Inbound and outbound is always determined by looking at the position of that person. So if this was a gigabit interface right here, okay, so let's say this is GI00 and this is GI01, okay, this is outbound because it's going away from the person in that particular router. This is inbound on G00. This would be outbound on G00. And this would be inbound on G00. So just imagine a person sitting in the router and determine in and out always from that particular point. Does that make sense?
It's into the device and out of the device.
Yes.
You're a little bit low there, Corey. You may have to speak up just a bit.
It's into the device and out of the device.
Correct. Into the device and out of the device. I just say person in the router because they think of a little person sitting in there moving packets around. There's a little Oompa Loompa in there moving around packets. And so that's how you can always know whether it's inbound or outbound, is by looking at the device itself. Now, Keisha, you talked about loopbacks. Loopbacks get real wiggy because loopbacks are, it should apply and it should work. And I'll be honest with you, you were talking about using it on in Packet Tracer.
Yes.
I would like for you to go and try whatever you were doing on NetLabs, and you may get a very different result using NetLabs versus Packet Tracer. So
Okay.
I'll do some research on that, but it should work. They should work and it should apply. You just have to be careful when you're looking at inbound and outbound, because you can source, like if you source a ping from a loopback, you're really still inside of the incoming interface, and so it may not actually apply to us. You have to be careful with that. But inbound and outbound, remember that. It's from the person sitting in the router, the little Oompa Loompa router person. All right? Now, the other thing about ACLs that a lot of people have a problem with is that ACL does consist of two parts. And one of the things you need to realize is that the ACE, or the access control entry, is an IP address as it is compared to a wildcard mask. Now, what is a wildcard mask? Another name for a wildcard mask is an inverse mask. Okay? So, with a subnet mask, what bits are significant?
The subnet mask, the ones.
The ones are important in a subnet mask because that tells you what portion of the address is the network and what portion is the host. In a wildcard mask, zeros are significant, not ones. But now, if I give you a wildcard mask and just say, okay, the mask is, let's just do this, 1, 2, 3, 4, 5, 6, 7, 8. That mask right there. What does that mask say?
That means everything must match.
Okay, it means all 8 bits must match. But this is useless unless I put another IP address. I put an IP address over here. Now I can make an assumption, but unless I have the IP address and the mask, I really don't have anything to compare, and I don't have an access control entry. But when you put these two together, what this means is if I put a permit statement here or a deny, let's say I put a permit statement here, this means allow only this one host. In other words, every single bit has to match. Okay, and it actually be 0, 0, 0, 0. So it has to be a 0, 0, 0, 0. That mask would be all zeros, all out here. Okay, I'm just going to do this. But all these would be 32 zeros. And that would mean every single thing has to match. Now, imagine this. Let's imagine I want to match the network 192.168.12.0/24. Okay? So I want a permit statement that allows just that network. The easiest way to do this is take the current subnet mask and everywhere there's a 1, convert it to a 0, and everywhere there's a 0, convert it to a 1. Or, even simpler, just subtract it from 255, 255, 255.255. 0, 0, 0, 255. So if I wanted to match this network, I would have a statement that was permit 192.168.12.0.0.0.255. In other words, I'm saying I want all the first 3 octets to match. Okay? They must match because this is significant. I could care less what's here because those bits are not significant. So this would catch every IP address from 12.1 to 12.255. Does that make sense?
Yes.
Keisha?
Yes, it does. I got that part.
Okay. So, I think people make wildcard masking much harder than what it needs to be because all you have to do is anywhere there is a 1 in the subnet mask, convert it to a 0 and vice versa, or just subtract it. But a wildcard mask by itself, too, is not all that important. Now, this would say here, I mean, you can say match all bits. You can say match the first 2, match the first 4, match the last 2, ignore all bits. But without the IP address to go with it, it's hard to say or do anything with it because you don't know. So here we look at this. If this is a wildcard mask of all zeros, and it's this, then that means it must match exactly. So this would be an ACL or an ACE example that only matches 1.1. Here's an example of all 255s. Guess what this says? This basically says ignore everything. So I don't care what's in there, I'm going to match, right? Yeah.
Yep.
Okay. Unless you do, if that's a wildcard mask, it's saying I don't care. Everything can be matched. And then down here's an example of matching just one subnet. Okay. And then here's an example of matching just a the elements network, just a subnet. So you got a mask of 15.255. So in other words, you have decided that the 16 to 31 network is the one you're going to match. And all they did was they took the subnet mask that they had before, which was what, 255, 255, 240, correct? And they subtracted that from 255, 255, 255, 255, and they're saying now match 16. But notice, this is not, this right here by itself, this mask, would not tell you to match 16 to 31 unless it was coupled with that particular IP address. Because the 15 tells you to match 16 to 31. Now this one's weird down here because this one confuses people, okay? But you'll notice, remember what we've said, in order for something to be odd, the 0 or the first bit has to be turned on, right?
Right.
Well, with this mask, which looks very funky, and it's not something you're going to do much of, but just in case you were doing it, this mask says, we've got to match the first two octets. They have to match exactly, okay? The final octet, the fourth octet, we don't care about, so anything, any IP address. In the third octet, we want this to match, which means we compare this mask to here, all right? And we're saying it's got to have a 0 in the first bit position. That means it's going to match all subnets that are odd. So .1, .3, .5, .7, .9, and so on and so forth. It's going to match all the odd subnets. Now, I'm going to ask you a crazy question. How would I change this example to make it match all the even subnets?
Say not
Nope.
the odd, no?
Would you
Nope.
just turn the two on?
Right. You would just say, guess what? I want this to be 192.168.2.0 instead of this compared to this mask, and now this has got a 0 here, right?
Mm-hmm.
Or you could do 0.0. That would work too, because that's got a 0 in this position. So all you have to do is put some IP here that has a 0 in that third octet's first position. Nothing changes with the wildcard mask, but we're still trying to see whether it's odd or even by looking at that bit position. So it's remember what I said before, it's the IP address. It's the IP address and the mask that matters. Questions about that?
Nope.
Yeah, I think I'm good there.
Okay. So, again, just subtracting from 255, 255, 255. It's the easiest way to do it. Or you could, again, change all the ones to zeros and all the zeros to 1. So your method is whatever you want. I personally do it the easy way. All right. There's also some abbreviations. If you're going to match all the bits and you want it to be a host, you can use the word host instead of having to write out 192.168.10.10.0.0.0.0. You can say host 192.168.10.10, and that says match all of the IP addresses. You also can use, if you're going to use quad zeros, any. So if you do 0, quad 0, 255, 255, 255, that says ignore all of the bits. So we can use any instead of writing out all of that, which is nice when you're doing an access list that's got a source and destination, an extended list. Here's some examples. Access list permit quad 0, 255, 255, 255. It's a standard list. You can just put access list 1 permit any, which shortens it. If you had access list 1 permit 192.168.10.10 quad 0, you can shorten that by doing access list 1 permit host 192.168.10.10. So pretty easy there. General guidelines. Here we go. 1 ACL per protocol, per port, per direction. Okay. Now they say per interface, but I like saying per port, per protocol, per port, per direction. Basically, this means you can have an inbound and outbound IPv4 and an inbound outbound IPv6 on each interface. And kids today, I'm doing my old man thing. Used to be we had to learn IPv4, IPv6, access control list. We had to learn IPX, SPX. We did some. Trust me, it used to be a whole lot harder than it is now. Now for CCNet, we're learning just basically standard access control list. Once we get into CCNA, the other two courses, you will learn extended ACLs and you'll learn some IPv6 ACLs. So, but remember, per protocol, per port, per direction. And the direction is from the person sitting in that little router. Some best practices. Number 1, the ACL should be based upon the security policy. That's a big thing there. I also will say that because ACLs are so dependent upon logic, I would write my ACL logic out first and then build my ACL. Okay. A lot of people use a text editor to build ACLs, and then they paste them into the devices, and they also keep the ACLs as text editor in the text editor. So if they do something similar later, they can just pull that one up and throw it, change IP addresses and throw it in. And then last but not least, I would definitely say do it, test them in a development network, because it's a bad day when you put an access control list on a remote device and lock yourself out and then suddenly can't get in that device and you're 3.5 to 4 hours away from that device. So there are some things you can do to help mitigate that. There's a reload command. You can say reload in 4 minutes. If you drop the ACL in and it knocked you out, that ACL will not be saved to the running, to the startup config, so it'll reload the router. The problem with that is then everybody at that site will be offline while the router's reloading. Not the best of ideas, but it is something you could do. Where to place them? All right. Standard ACLs go as close to the destination as possible because, let me get back over here. Standard IP ACLs, filter by source destination or source only. Filter by source IP only. Okay? They should be placed as close to the destination as possible. As possible. Okay? Now, extended IP ACLs, by the way, standard IP ACLs, if they're numbered, are 1 to 99. There's another range up higher we'll talk about, but that's the one we use mostly. Extended IP ACLs, they filter by source, destination, port, and protocol and other things. So they have a large number of items they can do, and numbers are 100 to 199 typically, and there's other numbers too. And you place these as close to the source as possible. Now, I compare them like this. Basically, a standard ACL is kind of like a shotgun. You just get in the ballpark. Whereas an extended ACL, that should be like a rifle and get super, super close, right exactly where you want to be. That doesn't mean that both don't have uses, because they do. But I will say in the real world, we use extended ACLs much more for filtering traffic. Standard ACLs may be used for simpler things like V2I line access and even some NAT ACLs and those types of things. Questions about these two before we go back to the curriculum?
Mm-hmm.
I'm good.
All right. So, one of the reasons to think about it is, let's imagine. Okay, I'm gonna do an example here, and I'm gonna do a change my color because I don't like the blue. I don't think it shows up as good. All right, we're gonna do an access control list, a standard ACL that is from this host right here. All right. What we're wanting to do is we want to stop this host from accessing this host or this network. First off, if it's standard, you can only use the source IP address, right?
Mm-hmm.
So I'm just going to make an access control list. I'm going to name it ACL or access list. Again, I apologize for my handwriting. It's terrible. 192. Actually, let's do this. Let me find my eraser. There. Smaller. Okay. Let's do access list 1. Permit. Oh, golly. Come on, y'all. Help me out here. Don't let me be an idiot. Access list 1 permit host 192.168, and I did a permit statement, so we're just going to say permit. We're only going to allow this one host access to this from our 10 network. Now, if we put that as an inbound right here, a couple things are going to happen. First off, what if this host, 1010, tries to go to 30.12 instead of 31.12. What's going to happen? So we use the IP access group command and we put it right here as inbound.
On this router one?
Uh,
Well, you should be able to permit it because you're permitting, if you're going to permit that source, it should be able to get out.
Okay, so it's going to be able to go out. Right, that host will be able to go out.
But
What's going to happen to poor little 192.168.10.20?
it's not.
When it tries to go out, it's not going to get out, is it?
no, the implicit implied.
So in other words, because what's at the end, right, it keeps us an implicit deny all, right?
Right.
Right.
So if we put it right here, we deny traffic we didn't mean to deny. Now, that's why as we do this, and we look at access control list, it's really why you should put it as close to the destination as possible. So it actually goes here, you go right here as an outbound. Okay? Now, we would still need to make some changes to this particular access control list, depending on what, if we only wanted 192.168.10.10 to access that network, that would be the way to do it. If we also want to allow other hosts, let's say we only wanted 10.10 from this network, but we wanted a host from 11, and we wanted the other hosts, what could we do? We could put in a deny statement, right? And we could do the rest of that 168.10 network in 0.0.0.255. So now we're permitting the one host, denying the rest of the 10 network, and then we could do a permit any, right?
Right.
Which is replacing quad 0 and 255.255, and put that as an outbound on gig 01. Now we're allowing host 192.168.10.10 to access this. We're not allowing anyone else on the 10 network to access anything on the 31 network, and then we're allowing everyone else. And you'll see here, this is why it's so important that we think about, the logic, because the very first entry that applies to a packet is going to be used on that packet. So if it comes in from 10.20, it's going to say, well, it's not this one, it's not 10.10, so let's go to our next one. Oh, we're supposed to deny that, throw it in the bit bucket. But if you had put these in the wrong order, if you had put permit and then put a deny, as soon as it applied to it, it would have applied and it would have been allowed through. So the logic of your access control list is super important. Does that make sense?
Yep.
Yes.
All right. So again, we're going to put it as close to the destination as possible for a standard ACL and as close to the source for an extended ACL. Here we are, numbered ACLs for standards are 1 to 199 or 1300 to 1999. You don't normally see that 13 to 1999 on any kind of test or anything, but permit deny statements, you can do remarks if you want to do a description or information about it, an access list. And you can use log, which will force it to log the information. So here's what would be the function of this list right here?
To permit the host on the 192.168.10.0 network.
Exactly. It permits all hosts on 192.168.10 network, and everyone else is denied because of the implicit denial or deny any at the end. Okay. So pretty simple syntax. Here we have a remark. This is permitting. That's basically saying what it's used for. It'd be nice if people use more remark statements than ACLs, but a lot of us don't just because we're lazy. Here we are. The important thing to notice too is when you create ACLs, it's not enough just to create the ACL. The ACL by itself does nothing. It's the ACL applied to an interface that's important. Okay. So here we've got the ACL created, and then it's applied to an interface in the outbound direction. So in this case, they're blocking it outbound going out to the internet. So basically, we're only allowing the 10 network to go out to the internet or to go up this serial interface. Everyone else, the 11 network, would not be able to get out. Right? So here's an example, no access list 1, that gets rid of the ACL, then you do access list 1, deny host, 10.10, and then permit everybody else. Typically, deny statements are going to go before permit statements, almost always. Okay. And here's an access list denying that host, permitting any. I think they're just using allowing everybody instead of just a one host. Instead of just the one network, they're denying the 1010 and allowing both, using it in a different position. Now that's one thing here you can see. Just because the rule is to say we're denying a specific host and permitting a subnet, so we're denying 1010 and allowing 10. The problem with that particular ACL is what happens. You'll notice traffic has to cross the router before it gets dropped. In other words, the 1010 host traffic would go into gig 00, it would get, there'd be a route table lookup, it'd do the switching into the router, and then go out after 00, and then it's finally dropped. Even though the rule is to put it at, close to the destination as possible, sometimes it makes more sense to do it like this. So in other words, there's a rule, and then there's real world. In the book world, you always put standard ACLs as close to the destination as possible. In the real world, here's a denying a specific host, denying 1010. This makes much more sense putting it on the inbound on gig 00, because then you're dropping the traffic before it has to go across the routing plane, control plane on the router. So you're saving CPU cycles. Both of them have the exact same effect, okay? But it is a better way to do it. This one actually, though, would block the 11, whereas this will not block the 11. The second one won't block the 11. Questions about that? Don't get confused when you see them break their own rules, because sometimes logically it makes more sense to put them in a different position than what the rule states. You also can have named ACLs instead of numbered. So you can do IP access list standard and then give it a name, for instance, web filter or web loud web traffic. Then you can do your permit and deny statements, and they're still the same source and source wildcard and IP access group in and out. If you're doing, this would be if you were doing a standard. Notice how it changes from to a new config mode we haven't seen before. Config standard NACL. So in other words, it's config standard named access control list. That's what the NACL stands for. You still have to create the list, and then you have to apply the list to the interface. Okay. So here's an example: access list standard, no underscore access. One of the important things to realize here, very important, is if this is all caps, the name is all caps, and you apply it, it must match. And the underscore must match. So if you had accidentally put in here NO access with no underscore, it would not work, because it's looking for that ACL, and if that ACL doesn't exist, it's not going to allow it to work. So very important that you pay attention when you are creating the ACLs, that if you use all caps, that you put it in as all caps when you actually apply it to the interface. Okay?
Mm-hmm.
But the exact same ACL using a named ACL instead of a numbered ACL. Let's see, yeah. You can use text editors to make your ACLs, so you can go in and build them and then paste them in. You can use, many people use text editors to do it. You can pull them out. You can do a show run, grab your access control list, dump them out, and then change them. Just realize that no access list really starts being applied until you apply it to an interface. So you do show access list all day long, and if you see the access list, it means nothing if it's not applied to an interface. So here's one way you can change them, just actually rewriting the whole ACL. You also can use sequence numbers. Okay, so when you actually do a show access list, you'll see that each one of the ACE has a sequence number, and if you want to change that one item, you can do the IP access list standard 1, which is, this is actually a named ACL called standard 1, and then you do no 10, and that will get rid of the 10 statement, and then you can replace it. So basically, you meant to put in 192.168.10.10, but you put in 192.168.10.99. Instead of removing that entire list, you can actually just go in and do IP access list standard 1. This assumes you're using a named ACL. So Now Cisco does, again, here's your you can even put in sequence numbers in between, so if you need to add something in between the two. By default, the sequence numbers are 10 apart, so you can add up to 10 different items into in between the sequence numbers. Then you can use show access list and you see your access list. Verifying ACLs do show IP interface, and you can see if an access list is applied. So show IP interface says 000 will show if it's applied. The only other way to see if it's applied is a show run, one of the few places. And you can do a show access list to actually see the access lists that are created. This is a good way to kind of look and say, okay, I've got the no underscore access list on here. Does it exist? Yeah, it does. Okay, it should be working. Very common with named ACLs for people to mistype the ACL's name. If you do put the log statement on it, you will see matches. So you can actually see the matches that are on there. It'll show you what has been, if it's being hit, which is important, especially with if you're doing NAT, using them for NAT, that's very important, and security, but for NAT it's very important too. Now, these same, up to this point, we've used two commands. We've used access list, and then we use IP access group to assign the access list to an interface. If you're going to apply access list standard ACLs to control traffic to your V2I lines, use a new command called access class. Now, this access class 21, the 21 is the name of the ACL or the number of the ACL you're using. And for V2I line and access to the V2I line is always going to be in. There's not going to be an out. So transport input SSH access class 21 in. Then you've got permit 192.168.10.000.255. You're only going to allow members of the 10 network, that would be your management network, access to the V2I lines via SSH. Everything else will be denied. This adds an extra layer of security so that not just anybody can SSH into your devices. And here they're showing you actually setting it up pretty much exactly what they just did. I would create the access list first, then do the V2I configuration. That's just me. But they show it the opposite way. I would have created the ACL first and then done the V2I line. If you want to try it, you can actually try to log in. You'll see that it's going to be refused from the 11 network. Will not be allowed. Questions about that one? I think that's pretty cool. Because we've learned how to do SSH. Now we're learning how to secure SSH even more by limiting who can have access. No questions. No all, see all, hear all.
No, I'm good on that.
All right, so remember the implicit deny any. If you're not careful, it will get you, especially if you don't put any permit statements in. If you did access list one deny IP 192.168.10.0 and then nothing else, everything would be denied. So be very careful with that. Again, be careful with the way that you put in your access control entries. The good news is the iOS will try to warn you. So if you do something like this, it will say it can't be configured because guess what? The 1010 is already part of the access list 3 statement. So you would have to go back and change either that sequence number, or you would have to go in and add a sequence before 10 that has the permit statement in it. So there, that would work. And then there's actually a logic inside of the access control entry with the iOS that typically it attempts to reorder things. All right, so when you got range statements and host statements, it will actually put the host statements first so they can be efficiently processed, even though you created them differently. You created it, you put your range statements, and then you put your host statements. But when you actually look at it, it's going to go in and change the ACL's order so that it does the host statements first and then the range statements. And so it will try to actually logically create the most efficient way for the access control list to be added in or to be processed. And then here's showing you how they're actually processed. So it arrives Is there an ACL on the incoming interface? If yes, does anything match? If yes, permit or deny. If not, it goes into the bit bucket. If there's no ACL on the interface, then it goes to the forward packet to the outbound interface. In other words, it does a route table lookup or uses Ceph, whatever. And then it's going to look on the ACL on the outgoing interface and says there's an outgoing ACL. If yes, then it has to match either a permit or deny statement, or it's denied. And then no, it just sends it on. So you'll see there's two different lookups. There's a lookup on both the incoming and the outgoing section. If you're going to block something or drop it on the outgoing, it's just as good to block it on the incoming. That way you don't have to do this entire lookup and then drop it on the way out the other side. Saves router processing. I'm going to let you go through these because it's not, from my standpoint of going through all these, basically, these each tell you about different errors. A lot of these are just errors in either logic or typing or applying them. So I'm going to let you actually go through these. A lot of these examples are not that difficult. They've just made a typing error or done, put in the wrong IP address range. All right, that, folks, is access control list. And all you have to really worry about is standard ACLs for the CSEN.
Okay.
So that is not a huge issue. Our next chapter will be Dhcp, which is also extremely easy. So that's the next chapter. One of the things I will mention in this lecture is don't forget that we are not, the class technically ends on May 9th, but don't freak out if you're not done by May 9th. You will have some time after that if you need to complete it. If you can complete by May 9th, that's even better because I can go ahead and accredit you and you can start teaching this class immediately. I will be sending out probably first of next week the hands-on skills file for you to do inside of NetLabs. And so I'll send you that, and then you will have that so you can upload it and get it to me when you get finished. Are there any questions?
Nope.
I'm good right now.
Yep.
All right, I'm going to stop my sharing. I'm going to stop my recorder.